So in this video, I'm going to discuss application of Green's lemma. The problem is the following: evaluate the line integral for the vector field given by this expression over the ellipse. I have a choice of evaluating the line integral directly or applying Green's lemma and getting this value. First, let me apply Green's lemma and show you the calculation. So that's a short statement of Green's lemma. This line integral is equal to this surface integral. All right. Now if I apply Green's lemma to evaluate the line integral, then basically I have to evaluate the right hand side. So what is dabba f2 by dabba x minus dabba f1 by dabba y? This is equal to, this is f2, so I partially differentiate this with respect to x, and what I get is 1 plus cos 1. Then I subtract the partial derivative of f1 with respect to y. So this integral is equal to just this. And what is that? That is nothing but the area of S. And what is S? C is the ellipse and S is the region covered, enclosed by the ellipse. So this answer is pi AB. So if you apply Green's lemma, this is how you can work out the integral. Now let's do it directly. And what we will observe is that an intelligent choice makes the calculations easier. Well, in this particular case, what made the whole thing very easy was the quantity, the integrand, is a very simple quantity. All right. Let us see what happens if we evaluate the line integral directly. So what am I supposed to do? I wish to evaluate this directly, where C is the ellipse and F bar is the vector field sin y I plus okay. So if I'm working out the line integral, I need a parameterization of this curve. So I begin by choosing a parameterization for the ellipse. So integral so this time I'm doing it like this, where it's obvious what y1, what f1 and f2 are. So f1 is the coefficient of I, therefore f1 is sine y. What is f2? F2 is x into 1 plus cos y. This thing is equal to integral f1 dx plus f2 dy. Since I'll be using this parameterization, I will prefer to write this as f1 dx by dt plus f2 dy by dt dt t going from 0 to 2 pi. Alright, t going from 0 to 2 pi. Okay. Now I will make all the necessary substitutions in this. So wherever I see an x, I put this substitution, I put this value. Wherever I see a y, I put this value. And the derivatives, again, to be evaluated from these two expressions. Alright, so this is equal to integration from 0 to 2 pi f1 dx by dt. So what is, this is your f1, sine of y, and y is b sine t. So f1 dx by dt. What is dx by dt? Dx by dt will be minus a sine t. Okay, plus f2. f2 is x, so this is f2. X is a cos t into 1 plus cos of y. And what is y? A cos y. Y is b sine t. Okay. that's f2, into dy by dt. What is dy by dt? B cos t. And one puts the dt over here. Okay, so let's proceed ahead and evaluate it. Okay, this is equal to integration from alright, so let me do integration by parts directly. I will choose this to be the first function and this to be the second function. Okay, fine. So first function, into the integral of this, what will be the integral of this? A cos t minus the derivative of the first, which is cos b sin t, into the derivative of this, so that's the derivative of the first function, into the integral of this, which is going to give me a cos t, 0 to 2 pi and 0 to 2 pi. All right. Okay. What about this term now? Now I will write it by splitting it into two integrals plus, okay, so a cos t into b, so plus ab times integral 0 to 2 pi of cos square t dt plus what remains, this into this into this. So this is ab integration 0 to 2 pi, this a and this b, and then cos square t and this cos square t cos b sin t dt. Just check that. Okay. And we will notice that these two things are same but opposite in sign. So these two things cancel off. There is no contribution from the bracket because sine 2 pi being 0, there is no contribution from the upper limit. Sine 0 being 0, there is no contribution from the lower limit. So what remains is just this, which we write as AB. Let me write it like this: 2 cos square t dt, and this is AB by 2 integral 0 to 2 pi 1 plus cos 2t dt. This is equal to AB by 2, and the integration of this is t plus sine 2t upon 2 0 to 2 pi. The contribution of this, whether it is the upper limit or the lower limit, is nothing. It's 0. The contribution of this term is there only from the upper limit, and I think it's clear that what you get is pi AB. So it's the same answer as you get when you apply Green's lemma. So when we applied Green's lemma, we had got this as the value, but the calculations in that case was easier. If you're doing it directly, the calculations are proving out to be more tedious. In some other situation, the exact reverse may happen. The line integral may work out to be easier to calculate. The surface integral, the double integral, may be more tedious. Okay, so one has to basically develop some intuition by working more and more problems. I think that's all in this video. These videos are actually being developed to benefit students of the Army Institute of Technology. The college has been closed because of government regulations. The government has asked the students to be at home. The colleges and universities in Pune have been closed because of the coronavirus pandemic. So these videos actually are being made for students of the Army Institute of Technology. I'm focusing more on the concepts. Alongside these videos, some assignments are being given to the students. After understanding the concepts, the students are expected to work out those problems and gain confidence in these topics. So my students and students of the other divisions of AIT are invited to subscribe to my channel, view these videos and give their comments. I made a couple of videos in the night time. Today I made 2 videos in the daytime, and I noticed that there was a lot of disturbance. My dog was barking, and then the maid came and rang the bell. Some construction is going on in the neighborhood. A lot of noise from the trucks. So the moral of the story is I should make the videos in the night when there is minimum disturbance. Well, I'll be waiting for the feedback from the students. The other students from the world community are also welcome to subscribe my channel and give their feedback. I will try to improve on the videos. You can even put your requests and demands. If you are interested in a video, if you're interested in a certain specific topic, I will try my best to cater to your requirements. Thank you.